Hello, welcome to the discussion of triangles that are no longer right angles, meaning triangles that are scalene triangles or isosceles triangles. Alright, first of all, let's examine what we mean by a triangle. Or simply put, a triangle is any plane figure which is enclosed by three close sides. Alright, here it is, we have scalene triangle. Yeah, triangle ABC. See that here? Alright, so here's vertex B, here's vertex A, here's vertex C. Alright, why is it a vertex? Well, two lines actually meet at a point. Alright, two lines here meet at a point. Two lines here meet at a point. So we have vertices. Alright, next thing, we have an angle here. A closed angle. Here's 46 degrees, here's 55 degrees. As a matter of fact, in this one triangle, in the horizontal triangle, we could actually produce two right angle triangles. So the right angle exists within the triangle. Alright, so you can actually get two right angle triangles existing inside this. Alright, now this triangle hasn't been drawn to scale. Alright, the next thing is that we need to know how to label the triangle. Alright, so the side that opposite the vertex, put in common letters. So here's capital C, the side opposite with vertex C, put it here as common C. Side here that's opposite vertex B, labeled as common B. Side opposite vertex A, we call it common A. Alright, this is the naming convention. Alright, there's no one set way of doing this. Alright, the convention is that we take the side as opposite the vertex, we leave it in common letters. Now you see that is the method that we use, we adopt. Alright, next thing, remember angle B was 46 degrees. We can represent this here in symbols by using this symbol here. Alright, here this means angle B, or you could have written it as ABC with the hat on top of the B. Alright, this means this here is your vertex. Notice that the vertex here is in the center. Alright, or you can just simply write it as angle B. Alright, remember where was angle B? Angle B was right here. See? ABC. Alright, so this is just notation. See? Angle B. See? E here is in the middle. ABC. Alright, so if you put it, you could note it this way. There's just different ways of representing it. So with these scalene triangles, you may wonder and ask yourself, how do you go about calculating the area of these triangles? Well, as I had mentioned, as we had realized, we can get two right angle triangles here. So you can actually get the area of this right angle here and then add it to the area of this. So you have half base by height across here and another half base by height here. Alright, I just assume you know this distance here. This becomes your base. Alright, from here to here becomes your base. So is there a shorter way of doing this rather than having to do this twice? The simple answer is yes. Alright, simple answer is yes. See, if you know this length and you know this length, alright, this side and this side, I know the angle between them, you can actually use a formula and work it out. In this case, we know this length and we know this side. This angle we know. So in this case, we just simply use a half A times B times sine C, or a half AB sine C. Alright? Alternatively, we could have come and say, if we had known the length of this side, alright, so we could have come and use this side, and this angle here. Alright, and that would be a half EC sine B. Alright, it doesn't necessarily have to be A and B. Alright, so you could use a formula here. The simplest way of representing the formula is a half AB sine C. Alright, so the area of triangle ABC can be represented as a half AB sine C. Simply substitute into the formula. Please ensure your calculator is in degree mode. Alright, punching in 55 degrees, sine 55 degrees. Multiply by 10, multiply by 15, multiply by a half. This works to be 75 sine 55 degrees, or 61.4 square centimeters. Alright, so you may wonder, do all Scalene triangles fit into this formula, a half AB sine C? What about a triangle with vertex P, Q, and R? What becomes that case? In this triangle, we have vertex P, vertex Q, vertex R, triangle PQR. Label the triangles. Here's small p, here's small r, here's small p. Alright, what do we know? We know the length of this side, we know the length of this side. We even know the angle between the side PQ and the side QR, the angle between these two lines here. Alright, so in a case of this would be a half PR sine Q. Alright, doesn't necessarily have to be A, B, and C. Alright, and this is how you go about applying the formula here. Alright, a half PR sine Q. Alright, so you just simply enter P as 18. You simply substitute P as 18, substitute R as 10, and substitute sine Q as sine 50 degrees. Alright, into this formula here. Alright, so you need to know your measurements, what values they have. Right? So P is 18, R is 10, and Q is 50 degrees. Alright, so this will be a half by 18 by 10 sine 55 degrees. Substitute inside here, and voila, there's your area. Alright, thank you for listening. Hope you learned something out of this. Alright then, have a great day everyone. Bye.